Assalamualaikum and hello everyone. In the last lesson, we learned how to express complex numbers in polar form. Z equal to R times cos theta plus J sin theta. Now, we will simplify it further using a very powerful idea introduced by Leonhard Euler, known as Euler's formula. Euler discovered a beautiful relationship between the exponential function and trigonometry. Look at definition 1.10. He showed that e to the power of theta j is equal to cos theta plus j sin theta, which is exactly this one. So, using this idea, instead of writing the whole things, we can now write it as simple as z equal to r times with e to the power of theta j. We call this the exponential form of complex number. But here, the theta must be written in radians, not as degree such in the polar form. Before we use this form, let's recall how to convert between degrees and radians. First, basically, we know that based on these findings, right? You can have a look at it. One complete cycle in radians is 2 pi, and in degree it is 360. So we can say that 360 is equal to 2 pi radians. So if we simplify it, it is 180 equal to pi radians. From this, we have the idea that 1 degree is equal to pi over 180. So to convert degrees to radians, multiply the degree by the pi over 180 radians. Now let's apply Euler formula in example 1.17. Let's look at 1a. So we already have r equal to 2 and theta equal to 30. So we want to convert the 30 into radians. So it is 30 degree times pi over 180. So which will give us pi over 6. So the exponential form for this question is this, right? Because r is 2 and the exponent of theta j, so the theta here is pi over 6. Next, part B. Here, theta is equal to 2 pi and r is equal to 3. So in the form of exponent, you can say that z equal to 3 e to the power of 2 pi j. Now, what if we start from a plus bj form? Let's look at 2a. So what you need to do, we'll need to find the r and also the angle. So let's look at the answer. R is 2 squared plus 3 squared, right? Square root, which will give you 13. And then we have the theta of 56.31, right? So this is obviously the first quadrant. But then we don't want this for the case of exponential form. You need to convert it into radians. So 56.31, right? It should be 56.31 degree times with pi over 180, which will give you the radians. So for this case, the answer is 0.9828. So in the form of exponent, it is the r 13 times with e to the power of radians 0.9828 j. That is the answer if you start from the standard form. Just like polar form, multiplication and division are much easier in exponential form. If z1 equal to this form, these equations, and z2 equal to these equations, so to multiply, you will need to multiply the magnitude 2, just like in the polar form, and you need to sum the theta just like in polar form. The same goes for division. It is actually similar to polar form, where the magnitude need to be divided and the theta will need to be subtracted for division. Now try exercise 1.6 on your own. You'll express complex numbers in exponential form and also practice multiplication and division. Start with question 1. Convert from polar or a plus bj to exponential. Then question 2. Test the operations using Euler formula. So let's recap. So what did we learn? First, we know that Euler's formula say that e to the power of j theta is equal to cos theta plus j sine theta. and the exponential form should be represented as r times e to the power of j theta. So the same as in polar form, when you're multiplying, you multiply the r and add the angles. When you divide, you will divide the r2 and subtract the angles. So next, we'll move to 1.7, which is the De Moivre theorem. Thank you.